This video demonstrates CREO mechanisms using a planetary gear set. We already have our working directory established, so first thing we're going to do is create a new assembly. So new assembly, and this will be called mechanism. And after we've established our new assembly, the first thing to do is to insert into the assembly the yoke. So I'm inserting the yoke into the assembly. We're going to place this one as a fixed component with constraint type equal to default. That lets the coordinate system of the yoke equal the coordinate system of the assembly. So let's click the check mark. Next thing I want to do, I want to go ahead and open an external gear. This external gear was created, let's turn on our planes, with a tooth that's not quite where it ought to be. So what we want to do is we want to put a coordinate plane or datum plane right through the center of that arc. So we're going to create a new sketch on top of the plane. On top of the top face, we'll project this curve here. And then we're going to draw a line from the origin to the midpoint of the plane. And get out of the line command, exit the sketch. Now we can create a plane using that line that we just made, and then holding down Control and selecting the top surface of the gear gives us a rotation, suggested angle of rotation for our new plane. The plane's located in the intersection in the correct spot, but we want to make it rotate 90 degrees. Hit Tab so I can preview that. There we go. Rotating 90 degrees, so click OK. And I'm going to rename this datum plane line. While I'm here, I can also right-click on this sketch and hide the sketch, just so I don't have to watch it all the time. We can also hide some of the other planes, so this will be useful. I'm going to hide the other default planes here, as the only one we really want to use is the one that's cutting through the center of the external gear. So with that saved, we'll go ahead and click Save. And I'm going to exit out of that gear. And in Assemble now we can bring in the external gear that we just modified. So open up the external gear. And this is going to be a pin connection. The pin connection will be through the axis of the gear. So I'm going to find the axis by selecting a cylindrical face. And we'll select this cylindrical face of the pin. For translation, the assembly item will be this top surface of the yoke, and the component item will be the bottom surface. And now for our rotation, we'll let this plane and the center plane going through the yoke be set at 15 degrees. And then I'm going to set that as the new 0 position and enable regeneration. Click the check mark and our first gear is placed. Now let's place another gear. This one will be eventually our planet gear. So insert this one. Repeat the procedure. This is going to be a pin. Selecting the component item first this time, I'll select that here. Oops. And then we're going to select the top face. So I think I can see the top face, there it is, of the yoke. And then for the rotation again, we have this plane and then the one that comes through the yoke. there. And this one we're going to set to 0 degrees. And check. While we're here, it might be a good idea to go ahead and color these gears different colors. So external gear 1, which will be our sun gear, I'll make red. The next gear, external gear 2, which will be our planet gear, I'll make blue. One more item to place. We're going to go ahead and place the internal gear. This is the ring gear. And same thing, it's going to be a pin. And we're going to let it reside, the center of the ring gear will reside at the center of the sun gear. And then for translation, we'll let the top of the ring gear reside with the top of the sun gear. And for rotation, we have another align plane drawn here, and we'll use the sun's align plane, and we'll set that to equal to 15 degrees, and then set that as the 0 position, and everything looks like it should be lined up and enable regeneration. Don't think I enabled regeneration in the second one, so I'm going to make sure that I did that. Placement, rotation axis, I did not. So I'm going to enable regeneration value here as well. And now we have our full assembly ready to animate using mechanisms. I'm finished using my planes now, so I'll turn them off. And let's go into applications and mechanisms. Alright, so I'm going to go ahead and expand my connections to make sure I understand. Connections 1 is between the yoke and the sun. Connection 2 is between the yoke and the planet. Connection 3 is between the sun and the ring. So now that I understand how those connections are coming to be, we're ready to make some gears. So we'll click on the Gears tab. I'm going to make this gear be a spur gear. For motion axis number 1, it's going to be connection 1. For gear 2, motion axis for gear 2 will be connection 2. And then for the pitch circle diameter, we'll enter in 2, since that is indeed the pitch circle of the sun gear. Apply and then OK. Our first gear is now established. For our second gear, we're going to leave this one as a generic gear, and for our motion axis, we're going to set connection 2 rotation axis. And for the second gear of this one, we'll use our connection 3 rotation axis. And for properties here, we're going to change it from the pitch circle diameter to user defined. And diameter 1 will be 1, and diameter 2 will be 3. That has to do with the gear ratio of the planet gear to the ring gear. And we're going to leave unchecked, do not create an internal carrier body. So we do want it to create that. So we'll click apply and OK. So there's our second gear created. Now I want to add a motor. So we'll right click on the motors and right click on servo and new. And for the geometry, I'm going to use connection 1. We're going to spin the planet, we're going to spin the sun gear. And for the profile, we'll change it from position to velocity, and we'll set this equal to 20. Now that we have that done, only thing left to do is to watch it. So we'll go to Analysis, right click on Analysis and click New. I'm going to change the end time to 40 seconds and we'll click Run. This is close. The gear is running backwards. So I'll click Cancel. Go back to our gears. Let's see, so let's reset the gears where they're supposed to be. So I'm going to edit all of the parameters, all of the individual items, which resets them to their home position. This one didn't reset, so I'll type in 0 here and reset it as well. So take a look here now, everything is settled where it's supposed to be. We'll go back into our gears, connections, gears, and it's the second gear pair. We'll switch the relative rotation between the gears. Click OK. Analysis and new. So all that looks good. We'll click run one more time, make sure it's running the way we think. And we'll click OK. And now we've saved the analysis. If we would like to play this analysis from a different perspective, we can move our mouse, move our screen to a different spot. Look at the analysis and right click, we'll click run. It'll recalculate it from here. It's warning me that I'm going to overwrite the available result set. So I'll say yes, and it will run it again. And then once we have a set the way we want, we can go to playback and expand the playback and right click on this playback and we'll click to play. And here's our screen that comes up, and from here if we'd like to we can capture this into an MPEG or maybe an AVI file, however we'd like to do it. So go ahead and click OK. It is now recording it as mechanism.avi and storing in that folder. That finishes animating this gear set.